Okay, this is for Honors Geometry for Lesson 85. Hold on. Gotta get my marker fixed. It's not fixing. Okay, so this is for Geometry Lesson 85. These are called cross sections of solids. And the first part you're going to have to do is just identify a cross section, like the shape of a cross section. So probably you want your books open to page 553 so you can look at cross sections, so you can actually see, them nice and neat instead of what I draw. But I do want to show you a couple of things about a cross section. So this is a cylinder. And then a cross section is just what it sounds like. Like if you come here and you cut a cross section out, you cut across it like with a sword or a knife or something, you cut across it, this would be a cross section. When it's parallel to the base, it's the same shape as the base. So because this is a cylinder and my base is a circle, when I draw or when I take a cross section of it that's parallel to the base, the shape of the cross section is a circle, okay? Then if I take a cylinder and I do a cross section that's perpendicular to the base, so perpendicular to the base, it gives a different shape. Usually, like 99.9% of the time, it's either rectangular or triangular. If it's a pyramid, it's triangular. It's rectangular if it's a prism. And a cylinder, we don't call it a prism, but you could think of it as a special prism with a circular base, okay? So like I said, the first things you're going to have to do is identify what shape is the cross section, if it's parallel to the base or perpendicular to the base, that kind of thing. Then you're going to be asked to find like the perimeter or the area of these bases. And so what I want us to do now is I want us to actually work through the practice together. So let me go ahead and give you the assignment on this, and then we're going to work through the practice together so I can show you how this works easier. Let's see. So you're going to do the warm-up, which is on page 553. You're going to do the practice. Well, we're about to do the practice. So practice, I think it's A through E. And then you're going to do a few selected problems. What are they? Let's see. 1, 2, 7, 8, 10, 15, 28. 1, 2, 7, 8, 10, 15, and 28. And this is due Wednesday. That's when that's due, is Wednesday. So again, warm up on page 553, practice A through E, which we're about to do, and then 1, 2, 7, and 8. Sorry, my 8's messed up. 10, 15, and 28, that's due on Wednesday by 4 on Wednesday by 4 p.m. If you have any questions on anything, you need to email me before Wednesday at 4. Anyway, so let's look at this practice. So the first thing, if you look at practice A, which you should be on page 555 now, that's where the practice is. So on practice A, you've got that picture right there, and it says if the plane is parallel to the prism's base, what is the shape of the cross section? Well, we look at the base of that. The base of that is a hexagon, so the cross section would be a hexagon because it's parallel to the base. Whenever it's parallel to the base, it has the same shape as the base. Then when you look at B right there, whoops, right there in all my writing, that's your B, so make sure you're looking at B. It says find the perimeter of the cross section of the square pyramid if the cross section is parallel to the base. One side of the cross section is 4 inches long. So it's telling you to find the perimeter of the cross section of the square pyramid. So it's telling you the base is a square because it tells you it's a square pyramid. So that means my cross section is a square. And it says that one side of the cross section is 4 inches long. So if this is my cross section and one side is 4 inches long and I want the perimeter of the square, that's 4s. So I just do 4 times 4, so it's 16. Inches. Make sure you've got it labeled. So show everything I've shown. Like yours should look just like mine. No reason not. Because you can rewind. If you get behind, you can rewind and watch it over and get it done. Okay. Then for C, we're wanting to find the perimeter of the cross section of that square pyramid. The cross section is perpendicular to the pyramid's base. So I just told you on the notes, if it's a pyramid and the cross section is perpendicular to the base, it's going to be triangular in shape. So I know I'm looking at a cross section that's a triangle. Now they're going to tell me certain things about that. The height of the pyramid is 14. So that means the height of my triangle is also 14. The height of my cross section is 14 because it goes all the way up the pyramid. And the base of the pyramid is 12 inches. So that's 12 right there. And I want to find the perimeter of the cross section of the square pyramid. Okay, so I want the perimeter. So if I need to find the perimeter, well, this is an isosceles triangle because it's a pyramid, so these two have to be the same, which means when I draw the height in an isosceles triangle, it splits the base in half. So this is 6. So hopefully y'all are already saying we need a squared plus b squared equals c squared. So I can find this side, which will also find this side. So that'd be 6 squared plus 14 squared equals c squared. And then 36 plus 196 equals c squared. Or you could just go to c being the square root of 6 squared plus 14 squared. You know, we've done that a lot. And so just put that in the calculator, the square root of 6 squared plus 14 squared. And you get about 15.23 because we are supposed to round it to the nearest hundredth. So that means this is 15.23 and this is 15.23. So then we just add 12 plus 15.23 plus 15.23. And that gives me 42.46. 42.46 inches. So that's the perimeter of that cross section. Okay. Then that was C. Now I want us to look at D. Find the area of the cross section. Each edge of the cube is 4 centimeters long. Round your answer to the nearest hundredth of a square centimeter. Okay, so this drawing is a little weird. Now I've got writing all over mine, but you should be able to see it better in yours. You see how the cross section is going through diagonally. So we have to be very careful with that. It's still rectangular because that is a prism. And I told you if they're perpendicular to the base, it makes a rectangular shape, not necessarily square. That's why I said rectangular. This is a cube. And notice how I've drawn on the cube and I've put 4, 4 because it tells us the side of each cube, each edge is 4 and 4. Okay, so I got to do a couple of things. So the cross section we're working with is a rectangle. Already said that. It's a rectangle. You can see right there it's a rectangle. The deal is it's going through diagonally. See how it's going through diagonally right there? So we have to be careful finding that distance. So let me draw the top of the cube. This is the top of the cube. Top of cube. This right here is the top of our cross section. Okay, these two right here are the same line. So let me change. Let me show you. Okay, it blacked out. So let me do this. This. Well, my marker doesn't want to open. Okay, so this red line right here is this red line right here. So this part is the top of our cross section. And this cube is 4 by 4. Well, that's a right angle. That's a right triangle. Specifically, that is a 45, 45, 90 degree triangle. So if this is 4 and this is 4, this has to be 4 square roots of 2 because it's a 45, 45, 90 degree triangle. So that means this top is 4 square roots of 2. Now this distance is the height of the cube. So it's 4. But getting this length, you know, you just had to see that. Remember, this is the top of the cube and these two are the same. And then this distance is just the length of the cube, okay? So then we wanted area of this cross section. So area of a rectangle is length times width. I'm sure you're writing that down like you're supposed to. And then you just do 4 times the square root of 2, which would be 16 square roots of 2, but we are supposed to round it to the nearest hundredth. So I want to take that 16 square roots of 2, type it on my calculator, and round it to 22.6 because it comes out to be this. So 22.63. And we are in centimeters and we are squared because it's area. So there's that one. And that's D. Okay, and then the last one on the practice that we're going to do, because we may do one other one in the homework, is E. So we're going to look at E. So E, we're finding the exact volume of that oblique cone. So I'm going to draw the cone just so I can talk about it. Now, it says oblique cone, like don't let that freak you out. You just have to do volume of a cone, remember, is, pi r squared times the height divided by 3. That's volume of a cone. It's an oblique cone because it's kind of tilted to one side, kind of shaved off on one side. If we want the volume, I need the height. Now notice I have this right here. But I need the height. I need this one, okay? So if we look down at the base, this is just the radius. If I had the diameter, I have a right triangle. And if my radius is 2.5, my diameter is 5. So a squared plus b squared equals c squared. It's a right triangle, and again, you can do that. Or some of you may recognize it as a pi tri. If you don't, it's okay, because I'm doing it this way. So that means I have 25 and h squared and 169. Subtract 25 from both sides. So h squared equals 144. So h is 12. So that's 12. Now, we are asked for the exact. Okay, that means we got to leave pi in. So pi times my radius, which is 2.5 squared, times my height, which is 12, divided by 3. And I have to leave it exact. So I'm going to do some reducing before I put it in the calculator, like 3 goes into 12 and leaves a 4. Then I'm going to multiply 2.5 squared times 4 and get 25. So it'd be 25 pi centimeters cubed because it's volume. So that's the way E works, okay? Then I think, this one. I want to talk about number 20. I didn't assign it. I wasn't sure if I was going to do it, but I want to show number 20. So this needs to be on your paper, like right underneath E or somewhere. Make sure that 20 is on your paper. It says, find the perimeter of the cross-section of the square pyramid shown. The cross-section of the pyramid makes a square, so it tells us it's a square. We already know it's a square. And I want the perimeter, so I know I'm doing 4S because I want the perimeter of this cross-section. The cross-section of the pyramid makes a square, and it's taken halfway between the vertex of the pyramid and the bottom of the pyramid. So if I draw the side of the pyramid, this is the side of the pyramid, side of pyramid. This is 4 inches. And then it tells us that it's taken halfway up. Well, the side of this pyramid, triangle, halfway up means I'm at the midpoint of each side. Guys, this is a mid-segment. So if this is a mid-segment in a triangle, that means it's half of the base. So this is 2. So if this is my cross section, each side is 2. So 4 times 2, 8. My 8s are terrible right now. 8 inches. So that's how number 20 works. That's just another thing you can do with cross section. And again, the lesson, we've already done the practice. Make sure you do the warm up. 1, 2, 7, 8, 10, 15, 28. Do Wednesday by 4. If you've got any questions, make sure that you email me before Wednesday. Okay. See you later.